All right, day 22. Uh, Hopefully it goes good today, because as always, I'm tired, and we'll see how it goes. So yesterday wasn't that bad, and maybe since it's a school night, they'll take it easy on us. Uh, One can only hope. It takes a few hours to stay in the ocean or raft for boredom to sink in. Fortunately, you brought a small deck of space cards. You would like to play a game of combat, and there's even an opponent available, a small crab that climbed aboard your raft before you left. Fortunately, it doesn't take the long to describe the rules. Before the game starts, put the cards to each player's on deck, your puzzle input. Then each game consists of a series of rounds. Both players draw their top card, and the player with the higher valued card wins the round. The winner keeps both cards, place them on the bottom of their own deck so that the winner's card is above the other card. This causes the player to have all the cards they win in the game ends. For instance, in this test, 5 cards. The first round begins with both players drawing the top card. Player 1 has the higher card, so both cards move to the bottom of player 1's deck so that 9 is above 5. Total, it takes 29 rounds. Once the game ends, you can calculate the winning player's score. The bottom card in their deck is worth the card multiplied by 1. The second from the bottom card is worth the value of the card multiplied by 2 and so on with 10 cards. Top card is worth the value of the card multiplied by 10. In this case, blah, blah, blah. So the game ends. What is the winning player's score? Okay, so in part 2, they're going to give us, I predict, 2 decks that are too big to actually simulate and that you're going to have to reason about outside of the system, which is, which I don't like, but that's life. So what I want is, I'm going to use a deck because that's what we want. And I want to say class game, and it is going to take starting deck. Let's say deck 1, which is a list of int, and deck 2, which is a list of int. None, and so we'll say self.deck1 equals double-ended q of deck 1, and self.deck2 equals double-ended q of deck 2. And now both players draw the top card of their deck. Player 1 has the higher card, so both cards move to the bottom deck so that 9 is above 5. So let's say self.gameover equals false, and def play 1, and let's say card 1 equals self.deck1.pop left, card 2 equals self.deck2.pop left, and let's see what it says. Player with a higher value card wins the round. The winner keeps both cards. I'm assuming there's no ties, that means. Let's make sure. Yeah, it seems like there's no ties. Okay. And so if card 1 is bigger than card 2, then the winner's card is above the other card. So that means that self.deck1.extend card 1, card 2. Otherwise, elif card 2 is bigger than card 1, self.deck2. extend card 2, card 1, and then else raise runtime error cards were equal, because we're assuming that can't be the case. Okay, and then if not self.deck1 or not self.deck2, self.game over equals true. And now we'll say play self, and that's going to return none. This is also going to return none. While not self dot game over, self dot play one. Okay, that's real easy. And now let's do winning score self, which goes to an int. And if not self dot game over, raise runtime error, game is not over. Otherwise, winning hand equals self.deck1 or self.deck2, whichever one is non-empty. And what I want to do is I want to port iter tools, and then I want to return sum of card times I for card I in zip of reversed winning hand and count from 1. Okay, iter tools.count1, so that'll be 1 2 3 4. So I reverse it and then do 1 2 3 4, which is what I wanted to do. Consider the following starting decks. And I guess I better def make dex raw, which is a string, and it's going to return a tuple of list int. So I better import tuple. And what do I want to do? I want to say hand 1, hand 2 equals raw.split on double new line, and deck 1 equals int line.strip for line in hand 1 dot split on new lines, and then skip the first one because no, that's not right. That's 1 and that's 2, and then I want to return deck 1 deck 2, and so now I have raw equals that, hand 1 hand 2 equals make decks raw, game equals game of, let me call these deck 1 deck 2, game of deck 1 deck 2 game dot play, and then assert that game dot winning score equals, and what do they say it's going to be? 306. So let's try it. That worked. So deck 1 deck 2 equals make decks raw. game equals game of deck 1, deck 2, print winning score, no, game dot play, print game dot winning score. Okay, so let's run this, and it says 32783. That's the right answer. You lost to the small crab. Fortunately, crabs aren't very good at recursion. To honor your honor's raft captain, you challenge the small crab game of recursive combat. Recursive combat still starts by sending cards into 2 decks. Because you series around to the few changes. Before either player deals a card, if there was a previous round of this game that had exactly the same cards in the same order in the same player's decks, the game instantly ends in a win for player 1. Previous rounds from other games are not considered. Otherwise, this round's cards must be in a new configuration. Players begin the round by drawing the top card of each deck as normal. If both players have at least as many cards remaining in their deck as the value of the card they just drew, the winner of the round is determined by playing a new game of recursive combat. Otherwise, at least one player must have not had enough cards left in their deck. As a regular combat, the winner of the round, if they won the round, takes the 2 cards placed on the bottom of their deck again so that the winner's card is above the other card. Note that the winner's card might be the lower valued of the 2 cards if they won the round due to winning a sub-game. If collecting cards by winning the round causes the player to have all the cards they win, the game ends. Here is an example of falling further without the game prevention rule. At least many cards in their own deck. Both players, the winner of the round is determined by recursing into a sub-game of recursive combat. For example, if player 1 draws the 3 card and player 2 draws the 7 card, so player 1 has at least 3 cards left, or has at least 7 cards left, not counting 3 and 7 cards that were drawn. To play a sub-game, each player gets a new deck for making a copy of the next cards in their deck. The quantity of cards copied is equal to the number on the card. During the sub-game, the game that triggered it is on hold and fully ineffective. No cards are removed from the player's deck. For example, if player 1 drew the 3 card, their deck in the sub-game would be copies of the next 3 cards in their deck. After the game, alright, well, I'm going to make a new class for this because it will be easier. And call it recursive game. And self.scene equals set, because we need to keep track of things that we've seen. And now let me read this again because I was really involved. Recursive combat, 2 decks. Before each player deals a card, if there's a previous round of the game that had exactly the same cards in the same order as the same player's decks, the game instantly wins in a win for player 1. Previous rounds from other games are not considered. This prevents infinite games of recursive combat. White surrounds cards to be a new configuration. So let's just so I think I just need to change play 1. So let's do this. And let me do def signature self, which is going to be a tuple of tuple int and tuple int. Okay, and I just want to return tuple of self.deck1 and tuple of self.deck2. So because this is tuples, these will be hashable. And let's say sig equals self.signature. If previous rounds from other games are not considered. The game is a series of rounds. The game instantly wins. Okay. both players to play a sub game. Each player ignites the quantity of cards. A sub game, the game the triggers don't hold. For example, gameplay where game 1 is the primary game. So game 1, round 2, round 3, game 1, round 4, game 1, round 5, game 1, round 6, round 7, game 1. Playing a sub game, round 1. The winner of game 2 is player 2. Anyway, back to game 1. Player 2 wins round 9 of game 1. Sub game. Playing a sub game. Sub game. During a round. Here's what I'm confused about. Before each player deals a card, if there's a previous round in this game that had exactly the same cards in the same order in the same player's decks, the game instantly wins. Previous rounds from other games. Okay, so I think that's right. If sig and self.scene, then and so I'm going to do it this way. Self.winner equals none. If sig and self.scene, self.winner equals 1. Okay. And return. Otherwise, self.scene.add sig. Okay, so then we add this to the signature, and then keep going. So now I pull the cards off. If there's a previous round in this game that has exact same cards in the player 1, okay? Otherwise, the round's cards must be in new configuration. Players change round by drawing the top card. If both players have at least as many cards remaining in their deck as the value of the card they just drew. Okay. If len self.deck1 is bigger than or equal to card 1, and len of self.deck2 is bigger than or equal to card 2. So I think that's what it's saying. The winner of the round is determined by playing a new game of recursive combat. Winner is determined by playing recursive combat. And let me just check one thing. D equals deck range 10. Can I do this? No, I can't. Well, this D5. Okay, I can do that. So, play recursive combat. Otherwise, at least one player must not have enough cards left in their deck to recurse. The winner of the round is the player with the higher. The winner of the round is determined. Let's say winner equals ... and else winner is determined by card. Winner equals 1 if card 1 is bigger than card 2, else 2. As regular combat, the winner of the round takes the 2 cards and places them at the bottom of the deck, again if winner's card is above the other card. Okay. And so now we want to say, again, if winner equals 1, self.deck1 dot extend card 1, card 2, else self.deck2 dot extend card 2, card 1. Okay, and that's it. And now this needs to change to self.winner. Okay, and now we need to play recursive combat. And so let's say recursive game equals game of each player continues to copy the next cards in their desk. The quantity of cards copied is equal to the number of the card they drew to trigger the subgame. During the subgame, the game that triggered is unholdably unaffected. No cards are removed from the player's deck to form the subgame. Okay. So recursive game equals game self.deck1, let's say list of self.deck1, and how many cards do I want? Card 1, and list of self.deck2, and I want card 2 cards out of that. I want to do recursive game dot play, and winner equals recursive game dot winner. Okay, because this should be recursive game. And walnut self dot winner, and okay, so now is this the same as my test game? 92631 548710. Yes. So let's say recursive game equals recursive game deck 1 deck 2, and recursive game dot play, and assert that recursive game dot winning score equals, and what do we say that is going to be? 291. Alright, let's try it. And let me comment this out just for now. Cannot pop from an empty deck. Because I did not check for emptiness. If collecting cards by winning in the round causes the player to have all the cards, they win and the game ends. Okay, so if not self.deck1, self.winner equals 2 and return. If not self.deck2, how did I do this? I'll do that down here. Not self.1, self.winner equals 2. If not self.deck2, self.winner equals 1. And then I don't have to return early. Okay, so let's try it again. Okay, that worked. So let's see if this works. recursive game equals recursive game deck 1 deck 2. So I hope I was wrong about that problem, because if I have to figure this out by hand, that will be real bad news. Three, 3, 4, 5, 5. All right, 192. Close to being the top 100, sort of, but not really. All right, good. So anyway, this is one of those where it's really a matter of just following the really detailed instructions and not getting them wrong. So in the first one, it's basically a game of war, right? And I put it in a double-ended queue just because you can pop from the left and append to the right, which is nice. So, to play one card, I pull from each deck, and, whoever's the winner, I give them the cards in the right order. And then if one deck is empty, I say the game over is true, and maybe I should have just done winner instead of game over. But I guess I didn't have to do that. And then to play, I just repeat that play 1 until the game over flag gets set, and then the winning score is just, basically I reverse it and then zip it with 1, 2, 3, 4, 5, and add them up, like they said, and then I parse the decks. Now the recursive game is an interesting part. And what I need to do is a couple of things. One is I need to keep track of hands that I've seen, so that if I get to a repeated state, I don't get a winner. Now, why did I not do that in the first one? I don't know. I probably should have, but it wasn't part of the rules. And now I track the winner instead of just as game over, because that's easier. And I write this signature helper function where if I want to put something into a set, it has to be basically hashable / immutable, whatever. And so it's a tuple of tuples, which is hashable and immutable, and it gives me a nice representation of each hand so I can see it twice. And now here, the play and winning score are the same. It's really this logic of, check if the hand is seen, and if it's been seen before, player 1 wins, because that's why. Otherwise, add this signature to the things I've seen so that when I see it again, I'll again pop the cards. And now here's this thing that says if the remaining cards in the deck is more than the number of card 1 and is more than the number of card 2, then I create a recursive card using that many cards from the deck. I have to put list on it because I can't slice a queue like that. So, but I want to make a copy anyway, so it doesn't really matter. I play the recursive game, and I just set my winner equal to the recursive game's winner. And if it's not recursive game, then I choose the winner based on again which card is larger. And now I do the same thing. If 1's the winner, I give him card 1, card 2. If 2's the winner, I give him card 2, card 1. And then I just check and see if anyone's empty. I declare the winner. Now I have to check who the winner is, and that's it. So really, I mean, for the most part, the hard things were one, knowing to use double-ended queue, although I guess you could use a list and it wouldn't really hurt you that much. It's ugly. And then the second part that's not good is just that the instructions were extremely detailed and finicky, right? And so you really have to read them and understand them and figure out how they work. So some days are like that. And so that's it's just a matter of reading and attention to detail and making sure you dealt with all those cases. So good. So that's that. And I will didn't take too long, and I will see you tomorrow.